All right, welcome. I am Ryan Holger with TEC. You are joining us for a two-part series. We are meeting this morning at 10 o'clock Central Time, and then again on Wednesday. I realize it's going to be a small group because I sent the notice out a little bit late, but more importantly, because it's summertime and most of you guys are busy. So if you have time to watch, great. If not, I'm recording it. So if you have coworkers who need to see this, that is totally fine. All right, so we're gonna jump right into stuff. As you can see, my contact info is up there on the bottom right-hand side. My coworker Dave is also up there because we made this class a year and a half ago. We actually thought we would be teaching it simultaneously, um, in person. This is the first time I'm doing it via webinar, by the way. Normally you do it in person. We've done almost 60 of these live. In any case, we thought we'd be doing it simultaneously because Dave's really good with piping and refrigerant and stuff like that, and I'm really good with controlled stuff. That's my background. But after we did the first class, we realized that nothing is actually different from the refrigerant perspective. Everything's exactly the same as what you're used to with 410A. And all of the new pain in your life comes from the controls widgets. Hence the reason why you guys get me instead of Dave. Now, obviously, there are a few things that will change refrigerant wise, and I will cover those. But I'm going to say things a lot like, hey, it's exactly what you used to do with 410A. Hey, it's exactly like what you used to do with 410A. It will get a little bit annoying, but there will be a few differences. But there's a lot of stuff different in terms of wiring. All right, so on the background side of the equation, I will spare you the 2 hour lecture on refrigerant changes over time and why we're changing them, blah, blah, blah. The fact of the matter is that the current rules that we have to deal with in the United States require us to have the global warming potential down below 700. I know my slide says 750. That's because that was the most recent number, but that final number actually ended up being 700. It was supposed to be, what was it? 550, no, 500, then 650, then 750, then they finally settled on 700. I don't know why they keep changing their mind. It's weird. There's not even any refrigerants that exist between 700 and 750 that I can find. So I don't even know why they changed it. But that's the kind of stuff that your government does. So we got to get all the refrigerants down below 700. We already got the ozone depleting potential down to zero for these refrigerants. So this is the next phase in that process. Here's kind of where we're at in the State of the Union, highlighted in yellow here. We're reducing the refrigerants that use or that have higher global warming potential. So specifically 410A and 134A are the ones that we need to eliminate. 407C, there's a bunch of them, right? But those are the ones we use in HVAC, as well as the equipment that utilizes those. There are two different things happening simultaneously. There's the phase down of the actual refrigerants, and then there's the phase out of the equipment that uses the refrigerants. So let's tackle the phase down first. This is the schedule for that. This process began 3 years ago in 2022 when the manufacturers were told by the government, right, the federal government that is, hey, you guys can only, produce 90% of the global warming potential that you guys used to do back in 2011 to 2013, so 10 years prior. You got to chop it down. That obviously causes prices of refrigerants to go up a little bit. Nobody really noticed because it was COVID and the price of everything was going up like crazy. So it kind of just rolled in with that discussion. The next phase down happened starting last year and continuing on right now, where they go back to those same manufacturers, the Kenmores, the DuPonts, those people in Honeywell and say, hey, you guys can only make 60% of what you guys used to make 12 years ago. Chop it down, man. And then the next step will happen in 2029, and it just keeps nickeling and diming its way down. And then it basically hovers down to 15%. And that's where it ends. It does not go down to zero. There is no actual phase out of these refrigerants, of the HFCs. So they can continue producing 410A, 407C, 134A indefinitely, but a much smaller quantity than they used to be able to produce. So it won't be readily available to everyone. That's a little bit different than R-22, which went all the way down to zero. Well, actually, I think it went down to 0.5%, but that's basically zero. So there's a little bit more buffer in this one, but it's happening in a faster window, whereas R-22 was a slow process. So that's what's happening with the refrigerants themselves. The equipment that uses the refrigerants has been phased out and is in the process of its installation being phased out. I won't go through every type of product, but we will touch on several that affect the majority of people that would be listening to this webinar or the recording thereof. Um, so specifically, let's start with package systems. So package systems are systems that the refrigerant system is installed at the factory, meaning that the evaporator and condenser are pre-piped together with each other in one box. So this would be like a package rooftop. It would be a gas pack through the wall system, something like that, right? Mainly rooftop units. The last day that those could be manufactured with R-410A or other similar HFC refrigerants would be the last day of 2024. It's the last day that those could be made. And the last day that they could be installed is the last day of 2027. So December 31st, 2027, 2 years from now, is the last day you can install a rooftop manufactured last year and prior with R-410A in it. That's the cutoff for that. Split systems, however, which would be like a residential split, a commercial air handler and condensing unit, a ductless mini split, anything where you, the installer, field pipe the condenser to the evaporator. If you have to do any field piping, that's a split system. Those had to also be manufactured by the last day of 2024, and they have to be installed by the last day of this year if you want to install them as a quote unquote system, meaning the evaporator and condenser at the same time. So if you install the evaporator and condenser at the same time, you have to get it installed by December 31st, 2024. If, however, you have I don't know, you have a condensing unit fail this year and you want to replace the condensing unit in January, but keep the evaporator. You can replace the R-410A condensing unit, assuming you can get your hands on one. You could replace that and keep the evaporator, and that does not count as a system install. That counts as a component replacement for repair purposes, and that is not subject to this rule. A complete install is the only thing that is subject to it. If you're looking for a loophole, probably not going to find it because A, the chance of you being able to get your hands on a new 410A evaporator and a new 410A condensing unit, both that fit each other, is low. And even if you do, legally, you cannot install them even like a day apart. I mean, I guess you could. You could install the condensing unit, pipe it up to the old evaporator, charge it, and run it. Then you can come back the next day and you can cut the evaporator out, pipe it back, pipe the new one in, charge it, and run it. Right? But you can't install them and not charge it and run it. So it's kind of like I know you guys are looking for a loophole. You're probably not going to find it unless you want to cheat, just straight cheat. Um, VRF, that's above 5 tons, is similar to other split systems, but it has a bonus year. So they can be manufactured with 410A this year still, but it cuts off at the end of this year, and they can be installed next year, 2026, all the way till December 31st, 2026. They get an extra year because VRF is more challenging because you have a larger quantity of refrigerant. We'll explain some of that in later discussions today. And then the rest of these things are more specialty equipment. You can see them on the slide if you need to. If you guys have questions as we're talking about stuff, type them in that question and answer, that Q&A box, and I will read them and we'll try my best. We'll try my best, like someone else is here with me. I'll try my best to go ahead and answer them for you. There are a few actual loopholes to this situation. I don't know if I have a slide for it, but the first loophole is that you can have the manufacturer can continue to produce 410A evaporator coils for use with furnaces indefinitely. There's no end date for that. So if 15 years from now, Carrier wants to make an evaporator coil for you guys to put on some old 410A unit for warranty or service reasons or whatever, they can do that. There's no cutoff date for the evaporator coil. These dates only apply to the piece of equipment that has the compressor physically in it. But they cannot produce the condensing unit. However, there's also a loophole for that. They can continue producing R-410A condensing units residentially and commercially indefinitely if they label them as service only, put a tag on there, a big, pink sticker, whatever, it says this is for service only replacement, and you cannot install this as a new piece of equipment. However, with that being said, almost no one is doing that, primarily because, in fact, almost no one, meaning I don't think anyone's doing it for small stuff. Primarily because in order to get an AHR rating, and you need an AHRI rating to comply with pretty much anywhere that has an energy code or to get rebates or anything like that either. But like 30 some states have an energy code, so to comply with it, you have to have an AHR rating, and you can't get an AHR rating with a condensing unit only under 135,000 BTUs, 12 and a half tons. So the manufacturers could produce for you a 3, 5, 7.5, 10 ton condensing unit only with no indoor component if they wanted to, but you had have nowhere to legally install it. So they're not going to produce that. Above 12 and a half tons, they have been doing that. They have been producing them in 2025 for use with existing evaporator coils. However, that is also diminishing. I know the carrier folks sent out bulletins um, in January saying they weren't going to do 60 tons and up anymore. They sent one in March saying no 20 tons and up. And I imagine that'll continue its way down to 12 and a half tons, and we'll probably have none of those this year. There is the opportunity to have agnostic coils, which basically is the generic statement for what would be considered a ADP flex coil. Assuming you guys have seen those. The original ADP flex coils, and we don't sell, ADP or anything. I'm just educating people. The ADP flex coils that came out last year were ones that you had one coil part number, and you could use it for R-22, 410A, 454B, or R-32, any one of those four refrigerants. You basically bought the coil, you told them what refrigerant you were going to use at the counter, and they handed you the expansion device for that refrigerant, and you put that on yourself. Since that point in time, there were some discussions and legalities with that, and the compromise ended up being that ADP was not going to be able to send that coil out like that because people might lie and say they're going to put it on 410A and then go ahead and put it on R32 and not buy any of the safety controls that would have been provided with the more expensive R32 version. So instead, the compromise is that ADP makes two versions of those coils now. They make one for non-A2Ls, so one coil for 410A and R22, and you tell them what expansion device you want, and then a separate coil for R32 and or R-454B combined. You still tell them what expansion device you need, but it comes with the safety controls related to that. And then when you get that coil, they give you two stickers in the box, 32 and 454B, and you stick the one on there that you actually installed, so that way the guy servicing it behind you knows what the hell's going on. If there's any questions, as I mentioned, type them in. I enjoy fielding questions, so in order to make this as fun as possible for me, type something in. All right, so all the HFCs were losing from an HVAC perspective. So 407C, 134A, 410A, and all those favorites are going away. They're being replaced with new refrigerants. If you're not aware, the EPA has this thing called the SNAP rule. The SNAP rule defines all the various refrigerants that can be used for various kinds of applications. This is the list of refrigerants that SNAP has for the residential HVAC equipment as well as light commercial. So basically things with swirl and rotary compressor for the most part. This is the list of that the manufacturers can choose from. There are 6 refrigerants on here. All 6 of these refrigerants are in fact flammable. This is the only list they have to pick from. So no matter what, you're going to get a flammable refrigerants. I guess you could pick from these 6, or you could pick CO2, but nobody's really designing around CO2. So you're going to get one of these flammable refrigerants. Um, so we got to learn about that no matter what. The good news, I guess, if there is a silver lining, is that only 2 of these are going to be in play. 4 of these, the manufacturers have elected to not use. The bad news is there's 2 in play. So 410A is being replaced by 2 separate things depending on what manufacturer you're dealing with. So, for example, R-32 has been selected by primarily Daikin and any of the Daikin family of products, right? So Goodman, Amana, and those folks. And some of that is related to, I assume, the fact that Daikin is the patent holder for R-32, even though there are multiple manufacturers of the refrigerant. I'm assuming Daikin wants to use what they have invented or what they've created, etc. So Daikin is going that route. Additionally, I'm also assuming because they already had R-32 in other countries, in equipment, it's easier for them to do that for the United States. They say, hey, we go to Europe, we take this design we got over there, we switch it from 50 hertz to 60 hertz power, test it, import it to the United States. Our R&D is done and they're ready to go, right? The other manufacturers, most of them, and there's other ones that have R32, like we have Gree with R32. We have some very large carrier commercial condensing units with R32. It's not just Daikin, but it's mainly them. Everybody else, for the most part, has picked R-454B. Everybody else, meaning carrier residential, carrier light commercial, train, um, Lennox, Rheem, all of those kind of brands, right? And all the brands related to that stuff, Heil, Bryant, American Standard, et cetera, et cetera. They all picked R-454B. At one point in time, I believe I saw something with Train picking R-452B. This is like 5+ years ago. And then they bailed because no one else had that, and they all kind of settled in on R-454B. The reason the other manufacturers picked R-454B is twofold. One, it is most similar to 410A out of those six they could pick from, which meant the least amount of design changes required, hence the fastest R&D for them. And then two, at one point in time, they were told the global warming limit was going to be 500, in which case R-32 would not have made it. And as I told you earlier, the final limit that the EPA issued ended up being 700, so both of these refrigerants became viable. Hence the reason why you have two refrigerants to deal with in your lives. All right, if we look at a few of these side by side, we'll look at 410, R32, and 454B. We will ignore the other ones because no one's using them, so they do not matter to us. Obviously, 32 and 454B are below the 700 global warming potential limit. R410A was three times the limit, hence the reason why it's leaving. From a capacity standpoint, how many BTUs of energy could we shove into a pound of refrigerant? R32 can move a little bit more energy than 410A could move. R454B moves a little bit less energy than 410A could move. That doesn't mean equipment will necessarily be more or less BTUs on the label. Depends on other factors other than the refrigerant itself, coil surface area, etc. But just to get it from a refrigerant pure discussion standpoint, that's the deal there. Coefficient of performance. How efficient is the refrigerant? COP. Both of these are like one click better than R410A. Like not noticeable. Like what used to be a 15.2 SEER box might be a 15.3 SEER if it was had the new refrigerant in it. It's so small that no one's going to notice, but slightly more efficient is better than slightly less efficient, I suppose. Evaporator glide. This may or may not be something you guys are familiar with, primarily depending on your age, depending on how old you guys all are. When I started here in the mid 90s, we were just getting used to using 410A in general as an industry. Carrier was the first ones using that, and I worked at a carrier distributor, so we were kind of just getting involved in that. And the glide thing came up a lot. So if you didn't know, any refrigerant with a 400 series number means that that is a blended refrigerant, meaning it is two or three things mixed together to make one refrigerant, right? So R22 is not a blend. R32 is not a blend. But 410A, 407C, 454B, those are all blended refrigerants, more than one thing mixed together. If you have two refrigerants mixed together, those two things do not likely have the same boiling point. So they're going to evaporate off at different temperatures in the evaporator coil. The glide is the difference in temperature at which they are going to evaporate off. And unfortunately, it's expressed in Kelvin on this chart, which none of us have our minds wrapped around. Um, but for normal evaporator temperatures for 454B, 1 degree Kelvin. That's like, I'm going to call it 2.5 degrees Fahrenheit. So refrigerants traveling through the evaporator coil, boom, right here, one of the two refrigerants inside there starts evaporating, and then X number of inches later, the other one starts evaporating. And the concern, at least when we had 410A back in the day, even though it had a lower glide and everyone was freaking out about it, they freaked out about the higher pressure, right? And then they freaked out about the glide. And they were like, oh, dude, if there's a leak in the evaporator coil, we're not going to be able to fix the leak and then top it off. We're going to have to recharge, pull the charge out and recharge it from scratch. No one has ever done that with 410A ever. And no one's going to do that with 454B ever. 1 degree of Kelvin glide is not enough that anyone would notice. And if it did leak out at that exact point in the evaporator and then you did fix it and top it off, and your percentage was a little bit off on the mix of the two, it is so minor it would not matter. And if you had so much leak out that it mattered, well, that means you're adding so much more back in to dilute it back down. So it's a non-issue. It's come up with a few people. Most people have no idea what glide is. So if you don't know what it is, you can ignore this. Now, if you were over here with a 5, 6 degree glide, that might be a little bit more noticeable. But we're not using those refrigerants, so it doesn't matter. From a pressure temperature relationship, these are all in the same general category. It's not like when we switched from 22 to 410A and we had a giant change in pressure. These are all kind of in the same realm. Let me see if I can pull up the PT chart I had queued up for you guys. Let me get this out the way. All right. I don't know if all you guys can see that. I'll zoom in even more. Maybe I won't. Can I zoom in more and go bigger? There we go. All right. And I can send this to you guys via email if you like. This is 410A over here. This is 454B, and this is R-22 on the side over here. And a couple other ones, R-32, right? Um, do me a favor, type something in the question chat box for a R410A temperature that you want to compare it to, or pressure. I don't care either way. Just throw something in there so we got something to debate about, or at least look at. While you guys are typing something in, hopefully you are. I'm gonna go pick a very common one. Everybody seems to yell out. For some reason, everyone always yells out 32 degrees. I don't know why that happens because 32 degrees is not a refrigerant temperature you normally would have. But if you were, here'd be your pressure, negative 14, 28 for 454B, 33 for R32. If we go to something that's more normal, let's say we're operating at more like 45 degrees. R-454B would be 40 at that pressure, and R-32 would be 47 at that pressure. Right, so these things are pretty similar. If I go way higher, let's say I go to like, I don't know, let's go up here, 366. So 110 pressure, 366 degrees for 410A, 346 for 454B, 375 for R32. So R454B is going to be operating at a slightly lower pressure than R410A was. R32 will be at a slightly higher pressure, but they are in fact in the same general ballpark. By the way, you guys suck because no one typed anything in, so I don't love you anymore. No, I'm just kidding. All right, so as I mentioned, 400 series refrigerants are blended refrigerants. Two-digit refrigerants are not blends of refrigerants. So R410A, if you did not know, is a blend of R32, 50% R32, and 50% R125. R32 is the flammable refrigerant. That is the one that is causing all the other refrigerants to be flammable. In the case of R410A, we mix the R32 with R125, which is a flame suppressant, and when combined, we have a non-flammable entity. However, in the case of R454B, we have more R32. We have 69% instead of 50, and we're mixing with 1234YF, which is also a flammable A2L refrigerant. So we got two A2L flammable refrigerants mixed together. That means R454B will also end up being a A2L flammable refrigerant. So it stays flammable. When they gave me this slide, oh geez, almost 2 years ago at this point, and I saw the propane thing here with the big red line through it. I'm like, why do we have this slide? Like, why are you even talking about propane? What's it have to do with this? And they're like, oh, Ryan, people think propane is inside these new refrigerants. I'm like, why would they think that? And I started pulling people in my classes. Like I said, we did like 60, almost 60 live classes over the past year and a quarter. And a good percentage of people at some point in time believed that they were going to have propane refrigerant involved in their residential HVAC life. I don't know why you guys all thought this, but you did. I'm here to tell you there's no propane in R454B. There's no propane in R32. R32 is one single chemical compound with its ingredients right there. R454B is these two things mixed together, and that's it. Well, obviously they both have oil mixed in there, but that's it. There's nothing else. So there is no propane, there is no isobutane, there's no butane. None of those things are happening. Um, you may have seen this chart before on the right-hand side. This actually evolves from not evolves from, it comes directly from ASHRAE Standard 32, 34, ASHRAE Standard 34, which defines all the various refrigerants. ASHRAE is the one that defines those R numbers. They assign you R410A, they assign you R454B, R454C. They're the ones that assign that stuff. There's a whole another webinar if you want on how those letter designations get assigned if you're a total geek. But there used to be six categories of refrigerant. Now there are eight. As of almost 10 years ago, there's eight. But when there was 10, we had A's and we had B's, right? So A's meant that they were, as you can see, move my thing out of the way. that they were lower toxic refrigerants. B meant they were higher toxic refrigerants. Obviously, we'd like to work with lower toxic stuff when we can, right? That would be more desirable. Once in a while, you got to do something toxic, like maybe you worked on a big train centrifugal with R-123 back in the day, or maybe you worked on an ammonia chiller in an ice rink or something. Once in a while, we do that stuff. We'd like to stay in the A category where things are non-toxic. The one, two, and three means that it was what we would most of us say non-flammable, but technically it is flammable, but we call it no flame propagation, right? For the ones, you can burn R-410A. It is flammable, if you will. But when you take your torch off of it, it'll just go out. It won't propagate the flame. The flame won't spread through it. So you can burn it, but it's not what most people would consider flammable. So that's the ones. Two meant it was flammable, and three meant highly flammable, like propane and butane. You could use them as a fuel if you want to, right? That kind of thing. Well, all of the refrigerants that meet the global warming potential requirements that we have now with are off the table for being a non-flammable. The only one that's non-flammable that we could be using would be CO2, R-744, but nobody's using CO2 for whatever reasons. I think it leads to ginormously large systems. So everything else is off the table. We can't use it because the global warming potential is too high. So we had to move up into the A2 category, which kicks in tons of stuff in the existing mechanical codes all around the country, right? There's all kinds of extra rules when you have an A2 or an A3. Since no one wants to do all that extra stuff, somebody, I assume a couple dudes at ASHRAE, sat there going like, listen, man, we got all this stuff that's just barely over the line to be an A2. It's like right on the border. Like, what if we just change the line? What if we just like, hey, you know what? These things aren't A2s anymore. Now they're A1s. Good job, us. Now you can put them wherever you want. And then someone else was like, nah, dude, you can't just change the standard. Like, that's just kind of like, it's been that way forever. You can't change it. And then he's like, all right, well, hear me out, man. What if we make a new bucket in between the A1 and A2 bucket? We make a new one for all the stuff that's barely an A2. And we call it like A2 light. And then we can make new rules in the code for these things that are flammable, but barely flammable. This is, I don't know how it went down, but in my head, this is how it went down. Probably at a bar with three guys sitting there, right? So in any case, 9, 10 years ago, the ASHRAE standard came out with this A2L category. They took stuff like R-32 that was an A2 and they dropped it down into this new one, A2L. So the codes could be rewritten to be more flexible for this. Now, there's still going to be more rules. It's still going to suck. You're still going to hate me after today, but it won't be as bad as if you're using an A2 or an A3. To give you some scale to this bottom axis here is the burning velocity. How fast would the flame go if we lit the thing on fire? And up the left-hand side is the BTU content of it. You're used to A1s, which means you're these purple ones on the left-hand side, meaning they don't have a velocity. They don't burn on their own. So the velocity is zero. When you take your torch to R410A, it burns, but like it doesn't go anywhere, right? It just sits there, right? Whereas over here, here'd be an A2, R152A. It's used in propellants like hairspray or let's see if I have one. Or these air can things, right, to clean off your keyboard and stuff, right? It's used in that kind of stuff. And that is an A2L, and you can in fact burn it. If you ever made a blowtorch out of mom's Aquanet, you know what I'm talking about. The new stuff, A2L, that's these gold ones over here, or yellow, amber, whatever color that is. This box right here is the new A2L category that they carved out, right? So over here is actual A2s, here's A2Ls, and we're choosing from these six refrigerants over here, right? So here's R32, here's R-454B. R-32 burns faster than R-454B. R-454B has a little bit more energy content in it, but they're all over here in this bucket of being fairly mild. On the right-hand side is a list of stuff that will not ignite an A2L. So I suppose if you want to have a cigarette dangling out of your mouth while you're charging up a system, that would be okay. It'd be stupid. You probably shouldn't do it, probably against a bunch of rules somewhere, but technically it would not light it. But the things people ask about a lot are like, okay, what about a toaster? What about, Mrs. Jones, some elderly lady's at her house all by herself. She has a refrigerant leak in her house. She doesn't know about it. She goes to the toaster, pushes the button down to make her toast in the morning. Is her house going to burn up, in flames? It is not. The toaster does not have enough ignition energy to light the refrigerant. In fact, she could probably take the toaster, unplug it, go down to the basement, plug it back in, lean it so it's angled where the leak of refrigerant is, and it probably still would not be enough to ignite it, right? So a toaster's not going to do it. A hair dryer's not going to do it. Your Milwaukee drill's not going to do it, these kind of things. There's not enough energy. There are things over here on the bottom left that do have enough energy to do it. So there is stuff in someone's house that would have enough energy to ignite the refrigerant. And the main thing that we're concerned about, honestly, is your acetylene torch. Like you, the technician, is the most likely person that's going to start this on fire. You're going to cut into something that you shouldn't have cut into while it still had refrigerant in it, and that's when the mistake's probably going to happen. It's less likely anything in their house does it. Last couple things on this, and then we'll move on to, less general stuff, if you will. I'm going to give you this. You guys are going to have these slides for anybody who wants them. I'll email them to you. But this one right here, minimum ignition energy. It's in millijoules. Not that any of us deal with millijoules, but just for scale discussion. Here's R-32. It takes 30 to 100 millijoules to ignite R-32. That is more energy than like a spark plug in your car, right? So just not a lot more, but a little bit more. So it is pretty difficult to ignite it. R-454B is 3 times harder to ignite than R-32. And then for comparison, propane over here is 0.25. It's super easy to light propane. You could bang 2 rocks together and get some propane to light. But that's not going to happen with these refrigerants we're talking about. It's much, much lower, if you will. I don't know how well this is going to work. I'm going to try it. I've never played a video through a Zoom before. I'm going to give it a try. We'll see what happens here. All right, if you're in the question chat box, let me know if you can actually see this at least and hear it. I can always talk over it.
See the test.
In fact, I probably will just talk over it. Hopefully, you guys can see it. Can you guys see the video playing with the old British dude? By old, I mean barely my age. All right, cool. Thanks, Ivan. All right, I'm gonna pretend that he's not even talking. I'm gonna mute it and I'll just talk about it instead of him and see how it goes for that. He's got 3 refrigerants lined up: an A1, an A2L, and an A3. This is actually a 10-year-old YouTube video. That's how long ago this was. None of this stuff is new. So when people you're talking to are freaking out about the new refrigerants, yeah, they're new for HVAC, but they're not new. We've been using these other than HVAC for some time. In any case, he's got a sparker here. He's got it hooked up to this jug of A2L, which happens to be 1234YF, which is one of the ingredients in R-454B, and he's unable to get it to spark. If you look at the back of the torch, I don't know if you guys can see my little highlighter over there. That's the only place you'll see anything happening. When he turns up the gas flow, which we'll do here in a second, you just turned up the gas flow, try it again, and you're gonna end up with the same result. He's not gonna be able to ignite it with a sparker here. A3, for example, right? Like propane, this will light up immediately. No problem there. That's how hard it is to ignite. I've been showing people that video. My office said not to show people that video. I've been doing it anyway. The guy who said not to do it retired, so I don't care. This one I'm going to try to play with audio because it's much better. And if it doesn't work with audio, just let me know and I'll just send you guys the link. But let me get the link queued up now so I have it on my clipboard. But I'm going to try to send it or play it because this guy's pretty good about describing it. It is like 4 or 5 minutes.
Our A2, our A2L, as well as our A3 flammability chemicals. We're going to be using 3 different ignition sources that are going to be common to equipment that we know. A silicon carbide igniter, a silicon nitride igniter, as well as a direct spark ignition using a Honeywell ignition module. So we're going to see what we have for flammability on these 4 different classifications of flammable gases. All right, let's light this stuff up. So we're going to start with our 134A. It's about 80 degrees outside, so we should have about 100 psi A in this pan. We're going to use the trigger to adjust the velocity a little bit. Yeah, nothing lit so far. And let's move on to our 152A. Should be around 90 psi A. Different velocities with the trigger. Yeah, still nothing. Okay, let's move on to our 1234YF. Should be around 104 psia. We're going to get this sucker really high. And yeah, still nothing. We could boil some sap out of mahogany too, and we can't get that 1234YF to light. What about some propane? R290, around 144. First, we'll do some down the regulator, but you can see that our propane lights pretty easy, and propagation is pretty high. It is a highly flammable. Yeah. Okay, what about an open flame? We'll start with our 134A again, and yeah, there's nothing going on in there. So let's move on to our 152, our A2. Yeah, actually getting just a little bit of flutter in that flame. Not a lot, but you can see a little bit. How about our A2L? Yeah, almost nothing. Okay. Okay, let's invert this can and see what happens when we go from liquid to vapor. Oh, look at there. A little bit of ignition on this igniter, not on that one, and nothing on the intermittent ignition. Okay, now let's try our A2, our 152A. Holy HFC's Batman. Look at that flame. That's with an A2 converting from liquid to vapor, and not so much on ignition. And the moment we've all been waiting for, our A2 at home. Hmm. And not really a lot. More like an A1. Now there's a little bit of flood, but absolutely nothing on our chronic ignition. Oh, if I get it just right. And super, super hot ignition. Okay, let's see what happens with a direct flame. So our 134A, yeah, I mean, it's a little bit in there. Not a lot, but a little bit. As we increase our velocity, our propagation actually goes down. Well, what about our 152? Yeah, that's a lot of flammability. That was our A2. Let's take a look at our A2L. And, well, yeah, there's a little bit. So a little bit more than an A1, but definitely not as much as an A2.
Guess which student has a better chance of getting into an Ivy League school? First, take a look at Zach.
Wonderful commercial.
So what does all this mean?
All right. So that's from the ESCO Institute. If you're not familiar with them, it's like a training organization. It's great that they put some of the stuff out there on their YouTube channel. They have all kinds of training stuff on their website. They got some great podcasts as well if you're sitting in the car like many of you guys are with windshield time. So I just want to thank them because then I feel less guilty about using their stuff. I don't know how else I could have recreated that sitting here at my desk. Okay, a few other little nuggets for you. The American vehicle market started transitioning to A2Ls in 2012. So specifically, Cadillac was the first ones. They had A2Ls for 13 years now, specifically R-1234YF, which is one of the ingredients in 454B. In 2018, 6 years, 7 years ago, 50% of the cars in the United States sold had an A2L in them. It's highly probable the car you drove this morning has an A2L in it. I didn't believe that when I first heard this. I literally went out to my car and looked at the manual, and sure enough, it in fact does. So it's pretty common, much more common than you might notice it to be. This is the most current thing I could find, 2021 data for United States cars, and nearly 100% of the cars sold in 2021 had an A2L. I can't find anything after that because after that it became 100%, and hence there's no reason to make a chart. So every car sold in the country has an A2L in it already. I'm saying it like that because the guy that sold you the car or the girl didn't say anything to you. No one, when you walked in, was like, "Hey, you want the car with the flammable refrigerant, man? Let's go. We got you." Right? They didn't say anything. They probably don't even know, right? But they didn't say anything. They don't care. It's a non-issue. There's no disclosure required on their part. They're not obligated to say anything to you. And quite honestly, it's significantly less flammable than the 25-gallon tank of gasoline that's strapped to your car, right? I'm saying it like that because HVAC is the same thing, right? You don't have any legal obligation to tell the building owner or the homeowner that you're putting an A2L into their property. You have no reason that you have to say that. It doesn't make any difference to them. They're not cutting into the refrigerant system anyway. You don't have to do anything in that regard. And in fact, it is strapped to a furnace that is connected to an endless supply of natural gas, right? So that's significantly more flammable than the refrigerant. So you don't have to do anything. If you want to, I don't care. Feel free to tell people, but you don't have to. Now, I'm not saying you lie to people either. If Mrs. Jones is like, "Hey, is this that new flammable thing that I heard about?" Like, don't lie to her. Give her the information. I'm just saying you don't lead with it. You don't show up on their door like, "Hey, I'm here to install the flammable stuff today," right? It's not like you're leading discussion. From a building code standpoint, Obviously, a major change like this requires some changes to the building codes. This is a picture of the country screenshot back in 2023, showing that Illinois, where most of you guys are at, has not yet, been set up, or Wisconsin for that matter, set up for A2Ls. Indiana supposedly was. This is a screenshot from 1 year ago, and all of these states, except for Nevada and Alaska, were ready to go. Well, Massachusetts came a little bit later, but I've added my own checkbox on there. But that doesn't mean that everything's ready to go. So whoever makes this map, um, they're looking at most of the state, right? In some places like Wisconsin, there's a statewide mechanical code. So it's either they have A2L rules or they don't have A2L rules, right? But in Illinois and Indiana, where a lot of you guys are from, it's home rule. Every municipality makes their own mechanical codes. So some towns may have A2Ls allotted for, some may not. For example, the city of Chicago, the largest municipality in the Midwest, does not have any allowance for A2Ls. So what's the best way to say it? Illinois as a state has a state law that requires the municipalities to allow A2Ls. That is allowed. That is required. They're not allowed to prohibit A2Ls, but they don't have to make it easy for you to use the A2Ls. So the city of Chicago treats A2Ls like they treat A2s. All the rules for A2s are the same thing for an A2L. There is no special bucket for A2L, right? So that means, like most of you guys know, if you work in the city of Chicago, if you had more than 30 pounds of charge on a circuit of A1s, R-410A, you had to have a relief valve installed. Well, with A2s and hence A2Ls, that limit becomes 6 pounds. If you have a 6 pound refrigerant circuit, which is most systems, you have to install a relief valve, which is a couple $1,000s, right? Rules like that, right? So that just tells you like the state is good, is allowing it, right? So here's the language for Illinois. Here's the law for Illinois, SB 1804, that requires the municipalities to not prohibit A2Ls, but they can add restrictions to make it harder to do it. I'm gonna skip the legal stuff because that's boring. Plus, David typed in a question. Is it possible to email the video of this? Yeah, anybody who's registered for this webinar after Wednesday, I will send you guys the links. All right. There are two terms from the ASHRAE standard that we're going to pay attention to. There's a bunch of different terms, obviously, but one is refrigeration concentration limit. The other one is lower flammability limit. Refrigeration concentration limit is a number that ASHRAE assigns to each and every refrigerant to express how risky that refrigerant is. How flammable is it? Oxygen deprivation, toxicity, all those scary things wrapped up into one number, if you will. And every refrigerant has that, including 410A. We've always had that kind of stuff. We just haven't had to take any action on it really, for most part. Sometimes on VRF we did. Then there's lower flammability limit, all right, which is something we definitely ignored on our other refrigerants because there was zero, but now we have to deal with that. So this is out of ASHRAE Standard 34. The same exact table exists in the International Mechanical Code. It exists in the Chicago Mechanical Code, and pretty much every mechanical code cuts and pastes the ASHRAE table into their code. I cut the table off at R-22. It goes beyond that, but I cut it off for the moment so we can digest it real quick. Here's RCL, refrigeration concentration limit. It's expressed in three different types of units. The one that I personally have used historically in the past is pounds per million cubic feet. I don't care about metric things where I'm at, so that's what I've done. And the lower flammability limit, there's nothing in the table because none of these things were flammable. So for R-22, the refrigeration concentration limit was 13. If I go to 410A, right, it's 26. R-410A is half as risky as R-22, if you will. If I go to 134A, it's the same as R-22. Now my first flammable one, R-32, it's listed as an A2L. I'm going to call this 5 times as risky as R-410A, and stuff shows up in the flammable section. And most of the R-32 extra risk is because of the flammable stuff. It's not really like it's much more toxic than R-410A. It's because it's more flammable. If we add R-454B, I'm going to call that 8 times as risky as R-410A. And obviously there's stuff in the flammable section as well. For some of you guys doing chillers, you probably know that we have not switched to A2Ls on most large chillers. They're still using A1s. So 513A, 515B, 1, 2, 3, 3Z, D, E. I can't even say it. Those are still A1, so nothing in the flammable section for those. So what do you do with this refrigeration concentration limit? The first thing to understand is that there are two numbers there. Even though it only says one thing, it's actually two. There's the regular refrigeration concentration limit for regular buildings, and then there's the institutional occupancy limit. An institutional occupancy, for lack of better description, is a space of a building or the entire building even where people are not capable of removing themselves from the building in an emergency. So, for example, an ICU at a hospital, if there's a problem in the building and they got to evacuate you, you're probably not going to get out of the bed and walk out yourself. Someone has to take you out, right? So, hospitals, nursing homes, right? Things like that, daycare. A prison would be the same scenario, right? Even though you might be able-bodied, we're not letting you walk out on your own free will out the front door. We're going to take you out, right? So, those places, the limits all get cut in half, right? Just almost randomly picked. They're like, hey, we should cut all these limits in half. It's a double risky because it takes longer to get people out. So what do we normally do with this? Right? Here's the math. There's only two times we'll do any math today. This is one of those times. This is a real project from a little over a year ago. It was a large VRF system, 98 pounds. At the time, I rounded it off to 100 pounds. It was using 410A, so the limit would have been 26, but it was a senior living center, so my limit was 13 pounds per million cubic feet. And we've done this math on VRF systems since the beginning of VRF in the United States, which for my company was 2008. So with HVAC system, if there's a leak in the evaporator coil, the leak would be distributed to all the spaces ducted to that evaporator coil. So if I'm in a building with a rooftop unit and it's got 10 offices served by that rooftop unit and the evaporator has a leak, all 10 offices get the leak. So from the math perspective, we use the square footage of all 10 offices added together. However, in the VRF system, if you're not familiar with VRF, we have a little evaporator sitting up on the wall for each room, and they're all connected to the same refrigerant circuit. So I have those same 10 offices, but if there's a leak in the evaporator, it only goes into this office, not all 10. So I only get the square footage of this room, not all 10 added together. So it does make it a lot harder. But in any case, doing the math with 100 pounds of refrigerant, which is obviously a big system, but most VRF has a lot of charge. My 13 pound per million cubic feet limit, I could do the math to figure that out and find out that the smallest area that I could serve would be 7,600 square or cubic feet. And for a 9-foot ceiling, which this building was, that means 855 square feet. If I have any zones that are less than 855 square feet, I have to take them off the VRF system or I have to combine those two rooms into one room so the square footage is larger. We've always done that math on VRF. We've always had that struggle with the small rooms. We'll take it up to VRF. We'll give that one a PTAC or a single mini split or something like that. All right. It's always been going on. This engineer wanted to know what would happen if he switches to A2L refrigerants because his project timeline gets pushed out, right? So with R-454B, the smallest zone would have to be 7,000 square feet, which in fact was the whole building, which means it would be a useless thing. We couldn't use R-454B. And R-32 did not do us any favors. So we really couldn't even do the project with these A2L refrigerants. This is why on the deadlines, VRF gets an extra bonus year to figure things out versus the other split systems. They have to come up with another solution other than just doing it, right, in order to be allowed to have this. It sounds like what the solution is going to be for next year when these manufacturers switch to these refrigerants. It sounds like the solution is going to be that they're going to have isolation valves, automatic isolation valves. There'll be leak sensors in those particular zones. If there's a leak detected, they will shut off that zone so the rest of the pounds of refrigerant cannot leak into it. On smaller VRF, instead of having isolation for each zone, they might do it for each floor. Or on really small stuff, instead of each floor, they may just isolate the outdoor unit from the indoor stuff, and that might be enough to get the total pounds down. All right, the reason why we're doing this webinar is because many of you guys didn't come to the 60 or so in-person classes we have. And the reason we did the in-person classes is because none of you guys 2 years ago logged into the Carrier website or the ICP website or the Bryant website and did all the training modules they wanted you to do. So we're trying a bunch of different ways to get the information to you. On demand via the Carrier and ICP websites, in person at our buildings, and now via webinar that I'm just broadcasting to anyone who wants to listen at this point. At the beginning, they did have 3 training classes. Now there's a couple more, but there's 3 core training classes. industry safe application, safety storage transportation, and then install and service. I know there's six on here, but it's because they had it with and without NATE CEUs, and they charge you $10 to process the CEU. Otherwise, it was a free class. What I did here is I took all the information from those three classes. Excuse me. I combined it into this one class. Well, I guess it's today and Wednesday, right? And cut out all the duplicate stuff. Like we don't need to talk about the history of refrigerants at all three classes. Like cut that stuff out. I cut out stuff that doesn't apply to you. Like you guys in the field are not storing 10,000 pounds of refrigerant. Like we don't need that stuff. So we kind of slimmed it down a little bit to keep things moving along. So what are we going to cover for the next 25 minutes as well as Wednesday? We'll see how far we get today, but we'll talk about what's happening with the cylinders, storage briefly, transportation on your vehicle, your work van. We have to cover some general safety stuff just because we have to. We'll talk about things that are changing with your tools. It's not as many things as you think or been led to believe. We'll go through the installation and install practices, and we'll spend a lot of time talking about how to wire up these dissipation controls and how to troubleshoot them, because that's where the main newness is going to come from in your life. All right, from the cylinder perspective, as you probably know, all our refrigerant cylinders changed to gray. We used to have nice colors that before, pink for R-410A, for example, and that all went away. I have no idea why. We can't do colors anymore. I don't know if Crayola got pissed off and shut it down or whatever, but everything's gray. A2Ls are also gray, but now they're gray with a red band on them. So regular gray is an A1, gray with a red band means it's going to be flammable on there. All right, and it'll still have all the markings and the verbiage and the branding and stuff on here. So here's the Chemours one. They call it Opteon XL41, but as you can see down here in parentheses, it's R-454B. But it does have that red band along the top. So that's one thing that's changing, and that's fairly visible and obvious. The next thing that's changing is that the threads on the top of the cylinder for these 20-pound cylinders, and by the way, R-454B and R-32 are coming in 20-pound cylinders. So smaller than what you're used to with 410A, right? I'm assuming it's like potato chips, like just keep putting less and less in the baggie. I don't know what the deal is there. But it's 20-pound cylinders. It's probably related to some kind of transportation limit. But they're left-hand threaded for those 20-pound cylinders, meaning instead of righty-tighty, it's lefty-tighty. And that's annoying. The gauges that you're going to have, your refrigerant gauges, they're still right-hand threaded. The equipment, the condensing unit, is still right-hand threaded. Your blue, red, and yellow hose are still all right-hand threaded. Just this is left-hand threaded. So you will need an adapter to convert your yellow hose to connect to the refrigerant cylinder. This is both jugs of new refrigerant as well as reclaimed cylinders. You'll need this adapter. They're like 10 bucks-ish or so. Probably need to get two. You only need one, but you probably need two because you're gonna lose one of them. I noticed, like even in our training lab, a lot of people forget them on the end of the gauges, right? And then you don't notice until you use that same gauge later. The last thing that is changing is that we're getting rid of the rupture discs. So refrigerants you guys have been used to have had these rupture discs for years. Basically, this piece right here is a thinner gauge of metal than the rest of the tank. So when the pressure builds up too high in the tank, it ruptures there instead of blowing up the whole tank like a bomb. It's kind of like a fuse, right? It's designed to break. This is the spot. If it's going to break, this is the spot we want that to happen. We want the fuse to blow instead of the whole electrical circuit to go, right? We want this rupture disc to blow instead of the whole tank. It is not common to blow these. I've been pulling guys in class, and I lost count, but it's over 1,000 students at this point, between like the 60 classes, and it's like a dozen people I have found that have blown this so far, and it's almost always their fault. In fact, all but one has been their fault. Um, and they usually do something stupid like, "Oh, I was charging a unit at a restaurant in the dead of winter, and I need to heat the tank up, so I set it in the sink with hot water," not realizing that a restaurant usually runs 150, 160-degree water, unlike your house with like 120 and 130, and then they go back down and the sink and there's rooms full of fog, right? So we've had those for years. Those are going away, and they're replaced with a relief valve. The difference being when the rupture disc blows, you lose the whole charge of the tank. When the relief valve opens, you just lose enough charge to get back down under the pressure limit. So you might have had a 20-pound cylinder, it got too hot, hence the pressure got too hot. The relief valve opened up, it let some refrigerant out, and now you got 17 pounds in the cylinder. Whereas in the old tank, you would have had zero. That's the only real difference. And I assume this is because they just want less refrigerant to leak out and possibly become an issue. So because of those things, the left-hand thread, this relief valve, that does drive up the price of the refrigerant. The other thing, and I'm sure you guys are all painfully aware, is that it's been difficult to get 454B, or at least it was this spring and early summer. Now it seems to be okay-ish. But it was difficult to get R-454B, and it wasn't because there wasn't enough actual refrigerant. It's because they couldn't get enough tanks that had this relief valve on it. Whoever did the estimate on that didn't predict how much tanks they needed, or couldn't get the valve, or whatever their reason was, and hence no one could get tanks. So you had these giant tankers sitting at places with refrigerant, them like full-size truck tankers of refrigerant, and they had no way to put it into smaller tanks to distribute to you. So some distributors were buying 100-pound cylinders, which were available, and using those for contractors, right? And other ways to try to get things done. But I think we're kind of past that point now, or at least close to it. Um, some manufacturers also have started adding more charge to the unit. So instead of giving you like, 20 or 25 feet, 15 feet worth of line set, whatever it is, maybe they're giving you 30 feet worth of line set of charge in the unit to make it a little bit more palatable. So you don't need to get your hands on as much refrigerant for your project. All right, moving on. Cylinders are labeled. They got little flammable diamonds on them because they are a flammable refrigerant. They got the compressed air diamond on there like we had before. If you didn't know you were supposed to pop out the relief valve when you recycled one of these empty tanks, now they're not relief valve, rupture disc. But now because there is no rupture disc, they want you to, how do they word it? They want you to use a non-sparking piercing tool to punch a hole in the side of the drum. I don't know what that means. I don't know if that means our store is going to have a bunch of brass spikes on the counter for you. I don't really know what's going to go on there. But that's what you're supposed to be doing. Reclaimed cylinders, also left-hand threaded, also have a red band on them, also have a pressure relief valve on them. You are not allowed to put A2Ls into a standard recovery cylinder. You could, I guess, put an A1 into an A2 cylinder, but I don't know why you would do that. The cylinder costs more. So keep the A1s in here, keep the A2Ls in here. In fact, don't even mix the A2Ls. Some places are either buying back refrigerant from you, but they're only going to buy it if it's a single refrigerant, or they're taking it back for free, but if it's not a single refrigerant, then they charge you. So either way, you want to keep it separate. By the way, if you have any questions that come up, please do type them in the chat box or in the question and answer box, excuse me, and I will answer those. We have 20 more minutes today. We'll keep on moving. All right, as mentioned, I got rid of most of the storage slides because they involved storing 10,000 pounds of refrigerant, which neither you nor I are ever going to do. So that's like a discussion for another day. Things that we do have to pay attention to. Storing refrigerant in your building. For the most part, the simple answer is keep different chemicals separate from each other, right? Don't put the A2Ls with the propane. Don't put it with the acetylene. Don't put it with the A1s. Just keep everything in its own area of the building, right? Keep things separated. Um, that way there's less issue. Don't put it by flammable stuff. Keep a fire extinguisher in the area, right? Just general good rules like that. It's kind of the quickie answer, if you will. Um, you're not supposed to store the refrigerant above 125 degrees for R-32 and R-454B. That is the same exact temperature limit as 410A. And the reason it is the same is you saw the PT chart earlier. The temperature and pressure relationship of these refrigerants is all similar. So if we get to 125 degrees, that means I'm at approximately a certain pressure, right? 400 and some psi, and I'm trying to keep it under that so I don't bust this thing. Um, I am fully aware that your van at some point in time has probably been 100 above 125 degrees and you did not blow your tanks of refrigerant. There's probably some safety factor in that number. Maybe it really won't blow until you get to 135 or something like that. I don't know. Obviously, commercial kitchen hot water 150 is enough to blow it because everybody gives me that example. But 125 is right there at the border. That's the rule. In either case, it's the same rule as 410A. So whatever you were doing to keep your truck from being too hot before is the same thing you're gonna do to keep it from being too hot now. If you're not aware, for all of the chemicals you store, not just A2Ls, but A1s, acetylene, oxygen, whatever you're storing in your building, you are supposed to follow all the codes, obviously, have all the signage, have all the paperwork. If somebody came in, an official came in and say, hey, I need to see the MSDS sheets for all the chemicals you store. You should be able to hand them a stack of MSDS sheets saying, hey, here's where we keep the acetylene. Here's its paperwork. Here's where we keep the R-32. Here's its paperwork, etc., etc. I know a lot of you are not doing that today with your refrigerants. You're supposed to be, but you're probably not doing it. So this is just a polite reminder, if you will. Wherever you're storing the various refrigerants and other chemicals in your building, you should have the little safety diamond. The only thing that's going to be different now is that there'll be something in the flammable section, whereas before there was not something in the flammable section. Most of you guys probably don't care about the shop. That's someone else's problem. You probably care about the field if you're watching this video. Um, I got rid of all the slides that had to do with vans, and I replaced them with basically this one slide. Because all the rules changed last year, or at least the interpretation of the rules changed last year. So originally, they were going to require us to ventilate the vans, the service vans, if you had an A2L in there. I don't know exactly what that means. If you put one of those camper top things in there and open it up, I don't really know. You leave your windows open, I'm not sure. But you no longer have to do that. They were going to require you to store the tanks vertically and not allow horizontal racks for A2Ls. That rule went away, and you can use a horizontal rack. The reason that they had that rule is the relief valve, they want to be in contact with gas, not liquid. So by having it in the upright position, that would be the case. But they are going to let you put it horizontally, but it would be intelligent for you to rotate the tank so the relief valve is over here at the top end instead of at the bottom end, so it's still in contact with vapor and not so much with liquid. But you don't have to have the vertical storage anymore. And then they were going to make you placard all your vehicles. You no longer have to placard your vehicle either. You could just do exactly the way you do it now with your R410A. Um, if you have more than 440 pounds of chemicals on there, then you have to start placarding your vehicle. That's a lot of stuff to have on a service van. A delivery truck delivering chemicals, different math. But you in a service van, you probably don't have more than 440 pounds of refrigerant and chemicals in there. So you're good in that regard. So you don't have to do any of those things anymore. The reason you don't have to do it on your service van is because Chemours and other refrigerant manufacturers went to the U.S. Department of Transportation to get a clarification that you guys are considered materials of the trade. And we're putting that in quotes because I don't know exactly what that means. But basically, what it means for my purposes is that you are not delivering refrigerant to a job site. What you are doing is using the stuff on your van to install things at a project. It's a temporary situation. And for some reason, that gets labeled as materials of the trade. And you could have up to 440 pounds that way. But if you're driving down the highway with 300 pounds of refrigerant, materials of the trade service van guy, and there's a delivery truck right on your left hand side that has the exact same 300 pounds of the exact same refrigerant, he has to do placarding. You don't have to do placarding because you're a service van and he's a delivery guy. So it's just the way the rules happen to be. There are some other rules. Like we said, the refrigerant cylinders are 20 pounds for a reason. If you have larger refrigerant cylinders, then you have to go and do the placarding. To do the placarding, you have to have a U.S. Department of Transportation permit, which you would have to apply for. You are allowed to have the 20-pound cylinders. You are allowed to have up to 26 pounds of refrigerant in a piece of equipment. So if you're delivering a 5-ton residential condensing unit, it probably has less than 26 pounds in it. Hence, you can throw that on your service van. If you're delivering a 20-ton unit, it's going to probably have more, and you can't put it on your service van. However, a 20-ton unit is not going to fit in your service van, so it's a non-issue. So pretty much the kinds of things you would deliver in a service van, you're good for, right? If, however, you do need to have any kind of vehicle that is going to be having a piece of equipment with more than 26 pounds of refrigerant in it, you don't have to write your own permit request. You can instead become a party to the Daikin permit. They already have a permit for 26 to 44 pounds of refrigerant. And you could apply for a permit. Instead of typing up all the details, you can just cite their permit number and say, I'd like to use that permit. You still got to do the placarding, right? But you can use that permit. If you're going to have more than 44 pounds, you can be a party to the train permit and cite their permit number. Where's that? Maybe it's off the bottom here. Oh, it's at the top. Cite their permit number, right, and do the rules associated with that. And then from a cylinder standpoint, if you are going to transport cylinders that are above a certain amount, so above 20 pounds, but below 125 pounds, let's say you bought one of those 100-pound cylinders, you would need to get a U.S. Department of Transportation permit. You could become a party to the Chemours permit and cite this permit number. I know you guys are in the service van. You're not going to be the ones applying for the permit, but someone in your office may need that info if you're going to be moving something big at some point. I even asked if A2L recovery tanks need to be tested every 5 years like an A1. Uh, that I am not aware of. I honestly don't know. I didn't even know that was a thing for A1. Um, Also, I don't know most people that are using the same recovery tank. Usually they're recovering it, turning that tank in, and getting a new recovery tank. Like when you go to Home Depot and do the propane tank exchange. So I think without any effort, most people their recovery tank is being recertified by their recovery company and not by you, the field tech. So I honestly don't know, but I also don't know why you have a tank that you've had for 5 years, Ivan. You should probably have filled one up within 5 years. So I don't know the answer to that. I'm gonna say yes, it has to be retested and certified, but whether the number of years is 5 or not, I don't know. All right, you have to have a fire extinguisher on your service van. You're already required to have that. You're supposed to already have that anyway because you have other flammable things like acetylene on there. So that's not new. You just got to do it. You're not supposed to have your van above 125 degrees. That is already the current rule for R-410A, so that is not a new rule either. From a general safety perspective, let's hit a couple of the general safety things. Um, Refrigerant leak detectors. Obviously, if you have a leak detector that detects R-22 or 410A and it does not detect 454B or R-32, that's not super helpful then. You just need to make sure whatever leak detector you have can detect the thing you want to find. That's like a no-brainer sounding thing, but just check the specs of whatever one you own. See if it will, in fact, detect the new refrigerants, and if not, then you're shopping for a new one. When you go inside and start brazing stuff in the building, you need to bring your fire extinguisher inside, right? That is already a rule with A1 refrigerants. You have to do it still with A2Ls, and it's obviously slightly more important. You got to wear the proper protective equipment. I know this picture is horrible because this dude's wearing shorts and stuff like that. Um, but you need to wear gloves when you're working with refrigerant, any refrigerant, and you need to wear safety glasses. Maybe not full on goggles like this guy, but refrigerant in your eyes can cause problems. Refrigerant freezing your hands causes problems. These are not new things that you were unaware of. You already knew this. I am just reminding you. Right? Refrigerant causes frostbite, surprise, surprise, and it can cause blindness in your eyes. So that's just a refresher on that information. If you're going through a commercial building or whatever, and you're dragging a tank or two around the building on a cart, because you're going to make your way through the building to get to the roof hatch, you need to strap that stuff down to a cart. If you're carrying it by hand into someone's yard, well, then obviously you're carrying it by hand. There's no need to strap it down. All right, that's just kind of some general rules there. From a tool standpoint, you probably have been led to believe that you need all kinds of new tools. That was probably told to you by a tool salesman, because that's what I would say if I was selling tools. I don't sell anything at all. So I'm not trying to pitch you on something or not pitch you on something. I'm just here sharing information. Any tools that you're going to use around A2L refrigerants need to be non-sparking tools. So if you have a drill and it's old school and it has sparks shooting out the side, probably got to stop using that on the A2L job. All right. If you have a brushless DC motor in your drill, like 99% of you have, you're probably just fine. No new action taken, right? So things that have motors in them, we have to pay attention to those kind of things. In the interest of time here, I'm gonna skip all these individual slides, and I'm gonna go to the one you'll have them when I send you the slides, but I'm gonna go to the one that summarizes everything on one slide. All right. So from a gauge perspective, if you have digital gauges, which many of you do have digital gauges, you need to check on your gauge to see if it has the new refrigerants. Some of them do, some of them don't. Some of them will have R-32, but not 454B, that kind of thing. So you got to check to see what they have before you get to the job site, would be helpful. If your gauges, your digital gauges, do not have the new refrigerants on there, it's one of three scenarios. Either one, there's somewhere you can plug a cord in. I guess it's one of four scenarios. Somewhere you can plug a cord in and hook it to USB on your laptop and download the updates. That might be an option for you. Some of them I know guys in class have told me that their gauges talk to their phone via Bluetooth, and they can download the update to their app on their phone and then push it into the gauges that way. Right? The gauges just measure pressure, so they just need the PT chart installed in the gauge somewhere. Right? So you can do it that way. I've had a couple guys say that it's possible to send their gauges back to the manufacturer for them to update it at a cost, probably. And then the fourth scenario is that you just can't update them. They're so old, they're just frozen in time. It is what it is. Like you got what you got. Right? But you might be able to update your gauges instead of just buying new digital gauges. For those that are using analog gauges, you will have to get a new one, right? No one's going to give you like some kind of sticker that you stick in there. You can use your 410A gauges on 454B, right? But you have to ignore the pink band that your brain is trained to look at. Stop paying attention to that. Only look at the pressure on the outside of the gauge, and then go to the PT chart that I showed you earlier and be like, okay, I have this pressure. What temperature would that correlate to? You could do that if you had to in a pinch because you only had 410 gauges, like on your first 454B install. But after two or three jobs, that's going to get annoying, and you're going to want to buy gauges that have 454B on them. We did that in our training labs recently. We got new gauges with 454B instead of using the 410 and translating it because it was getting annoying. And the gauges are nice because they have 454B and 410 on there and a few other refrigerants. The problem is the 410 is on the middle circle, so it's so tiny you could barely tell where the you could barely tell what temperature it's at because it's so small of a circular part on the inside of the gauge. So it's not super useful to use it on 410. 454B on the outside was great. So we ended up in our labs anyway using our old 410 gauges for the 410 equipment, using the new 454B ones for the 454B equipment, and moving on that way. The hoses are all the same. Red, blue, and yellow hoses are absolutely identical, but you will need a left-hand adapter for one end of the yellow hose, the one that will connect to the refrigerant cylinders and recovery tanks. Um, what else? Vacuum pumps and recovery machines need to be A2L compatible. The ones you own might already be compatible. For most manufactured equipment, you can go to their site and you can get a list of all of the part numbers, the machine numbers that they have that are A2L compatible, or you go to the model number of the vacuum pump that you have, and it'll say on there if it's compatible or not. Essentially, is it spark proof or not? But you might not have to buy new stuff. You can just check it out that way. If you're looking to buy a whole bunch of new stuff, this is your year, right? You go to your wife and you're like, hey, got to buy new stuff. I need all these new refrigerant things. I got to spend 3 grand on tools. Just got to do it, right? It's for the kids, right? Right. Or if you don't want to buy stuff, then you might be able to make most of your stuff work if it's compatible. We're going to cover installation stuff in detail on Wednesday, but for the short term right now, here's the quickie answer. The things with 410A that we meaning the industry, we're telling you to do that were best practices, like, hey, you need to purge and evacuate, that kind of thing, they switched from best practices to being flat out required. None of the stuff is new that you have to do. It's just stuff that you didn't have to do before but should have done. Now you have to do it. By have to do it, I mean it's required by UL. Although UL doesn't really have anyone driving around policing behind you, but nonetheless, that is the requirement. You should probably do it. If you're the guy cutting corners, eventually that usually catches up with you. So just do it the right way, right? Before we were saying to do these things because it was good for longevity of the compressor, right? If we can get everything out of the line, it's better off, blah, 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 that kind of thing. So now it's just required to do that stuff. And we'll go through that. We'll go through those steps in detail on Wednesday as well. Recovery tank standpoint, as mentioned, they are left-hand threaded. They're still yellow. They have a red band added to them and do not mix the A1 and A2L refrigerants. And in fact, do not mix any refrigerants in the tank. Keep it singular. If you are in the area that we service in the Midwest here, last year, a year and a half ago, we started at 4 of our locations doing a tank exchange for recovery tanks. And now we do it at more locations in Illinois and Indiana. And I think it's going to spread to other places eventually. But there's a company we do it with, Hudson Technologies. Basically, you bring in a recovery cylinder that's full of any of these normal refrigerants, and then we would in fact take that back and pay you for it. Somebody asked me, so I was looking this is back in April, I looked, but it was basically $100 for a 30-pound cylinder is what we'd buy that off you for. And then we sell it to these Hudson people, right? And then they try to refurbish it, clean it up. If they get it and it's all mixed up and it's not one single refrigerant, then they don't give us the $100 and hence we don't give you the $100. But they don't charge you for it. They just don't give you the payment for it. Now, if you need to get a new cylinder, which you logically would need a new one when you give us this old one, you can get it from us or you can get it from somewhere else. It doesn't really matter. I obviously would like you to get it from us, but you don't have to do that. So they'd give you $100 for the 30-pound cylinder, and if you wanted to pick up another 30-pound cylinder, it would be 140. So basically, you pay $40. Or you just sell us the tank, and you got your other cylinder because you found it somewhere for $95. I don't know. If it wasn't obvious, the A2L refrigerants, 454B and R-32 are not direct drop-ins for 410A. You could probably put it in there. It probably would sort of kind of work for a while, but what things would break, I don't know. And then you also would have the liability when something went wrong. And maybe it would be fine for 99 out of 100 jobs, and then there's that one job where something goes wrong, and then you're in trouble. So just don't do it. Don't put the wrong refrigerant in the wrong machine. Whatever refrigerant it's specified for, use that refrigerant or another approved refrigerant. Like for example, if you have R-22 and MO99 is approved for it, you can put that in there, right? But 454B and R-32 are not approved to be put into any refrigerant systems that are not specifically those two things. All right, we're probably at a great breaking point. I've never actually finished at the exact time I was supposed to finish. This is the first time ever. It is 11:15, which we said was our breaking point. We're at the halfway point. So hopefully you will be joining us again on Wednesday morning at 10 o'clock Central Time. And we're going to go through the details of the installation process. And we're going to go through wiring the dissipation controls, troubleshooting the dissipation controls. That is on our agenda for part 2 on Wednesday. I'm going to hang out for like another minute or two in case you have any questions you would like to type in. Otherwise, I will hopefully see you guys again on Wednesday.